Okay, next we'll learn about the chapter about your electromagnetic spectrum. So electromagnetic waves are waves. So they are actually a group of transverse waves. So if you don't remember what a transverse wave is, that your motion is perpendicular to the particle motion. Okay, so just to write it over here, your wave motion is going to be perpendicular to your particle motion. Okay, this is the definition of a transverse wave. And if you notice over here, they all travel at 3 times 10 × 8 meters per second. And if you remember this value is actually the speed of light in vacuum. Now, why do they share this same value? It's because light is an EM wave. Okay, so do take note about this. And in your wave chapter itself, we have learned V equals to F lambda itself. All right. Now, basically, we have a bunch of your EM wave itself. You have a radio wave, microwave, infrared waves. You have your visible light, which is the light that we have been talking about and using in your chapter. And we have ultraviolet, X-ray, and your gamma ray itself. Okay. Now, the thing is, we don't need to memorize the numbers. Okay. Don't need to memorize the numbers, but you need to memorize the order that you are in. Okay. So do take note about this. Okay. So what I mean by this is you only really need to take note of is the wavelength and your frequency. And if you notice, these are actually the opposites of one another. So for example, radio waves have the longest wavelength, they have the lowest frequency, and vice versa for your gamma rays itself. So all you need to really do is just memorize one of them and just remember that which is correct. So now the problem is, how do we remember the order of your EM waves? So back when I was in school, the teacher taught us raging Martians invaded Venus using X-ray guns. So R for radio wave, M for microwave, I for infrared, D for visible light, U for ultraviolet, X-ray for X-ray, G for gamma rays. So the thing is, I can't really remember this this method. So for me, I remember it as now for your visible light. Okay, so for visible light, we know that you start from red all the way to violet. Okay, so red to violet. So the thing is, the EM wave before red, it is infrared, and then the EM wave afterwards is ultraviolet. Now, if you go and look up the English dictionary itself, the word infra means before, so before red, and the word ultra means beyond, so it's beyond violet. Okay, so if you work backwards itself, then you think about it, microwave and radio wave. Which one is more recent? Microwaves are more recent. After that, you have the very old radio waves. And if you do the other spectrum itself, ultraviolet, you think about it, TUV, UVX, right? So X-ray, and then last but not least is your gamma. Gamma, if you don't know, looks like a Y. So this is a gamma ray itself. Okay, so you can just imagine it's TUVXY and so on and so forth. So over here, this is how I remember it. I always start in the middle. Visible light, red to violet. So before red, that go by which one is the newest. Then for your ultraviolet, just remember UVXYZ. So ultraviolet, X-ray, and then gamma ray itself. Okay. So what does it mean if you notice over here, we have this non-ionizing and this ionizing itself, right? This is your danger level. This is not dangerous. This is dangerous, or this is, sorry, very dangerous. And then this is extremely dangerous. Okay, so basically you can see that it goes from here to here. So for your ionizing radiation, right, basically they are enough to kill you or cause cancer to you itself. Your non-ionizing itself, for example, microwaves and infrared, right, those will burn you. So from the sun, the light that comes from the sun is visible light, right? But for the sun itself, it's actually mostly discrete. So why we feel hot is actually your infrared radiation. So if you think back to your thermal chapters, we learned about radiation, right? And what radiation is that referring to? The radiation referring is your infrared radiation. So this is the reason why you will feel hot, because of the radiation from everyone. So that particular radiation comes from infrared radiation. Okay, So you know your microwave cooks food, your infrared cooks food. So basically, they can burn you if you are exposed to enough of such EM waves. So in terms of danger, radio waves are not dangerous. Microwaves might slightly burn you. Infrared will cook you. Your visible light is just lasers spamming at you. Ultraviolet will cause you to start to have skin problems, or you will tan your body, you have cancer. X-rays are very, very dangerous. Gamma rays will kill you straight. Okay, so you can see the danger level from left to right. All right. Now, next page over here, the thing is, for your EM wave chapter itself, it is not a very, very difficult chapter, but the thing is, there's quite a bit of things to memorize itself. Okay, so just remember, the first thing you need to memorize is that they all travel at this speed in vacuum, and they're all transverse waves, and you need to know the order that they're in, and apart from that, you need to know their applications. Now, there is one part that is more confusing, is this part. Television communication, and then you have satellite TV. So because of your current, because of the technology now, right, you can just ignore this part. Just remember, this is your digital TV. Okay, so when we are talking about satellite TV or digital TV itself, we are all referring to microwaves. Radio waves no longer are used for television already, so you can just ignore that part. And if you notice, there is this very cool name over here, radio frequency identification, also known as RFID, right? Another of your example is your EZ-Link card. Okay, so instead of using your, so when you want to go onto a bus or any kind of like transportation, right? Singapore, we use EZ-Link cards. So EZ-Link cards work using RFID tags. Okay, so do take note and then just look through all of them. For infrared radiation itself, you can see thermal imaging, and you can also use motion sensors. So sometimes in school, right, some of the toilets, they are actually motion sensors. So sometimes if you take too long to poop and you never move around, basically sometimes the light will shut down, right? So what you want to do is actually just move about, increase your body temperature, and then the sensors should be able to detect you again. Then for your visible light itself, you just need to say photography, your optical fibers, and your laser light, and so on and so forth. Ultraviolet is for sunbaits, and actually also for, you know, those kind of invisible ink, they actually give you UV light to actually show the parts. Same thing, if you want to prove that your banknote is real, you can also use ultraviolet light. So your X-ray itself, mostly for medical purposes, and also for your safety, security purposes as well. And then gamma rays is actually not so much for sterilizing food, it's more for this. This one, cancer, also not that much. Most of the time it is to kill the cancer cells. The problem is, so you see people in chemotherapy, they usually will lose their hand, all that, right? The problem is gamma rays are so dangerous that it can kill cancer cells, but at the same time, it's also damaging your health at the same time as well. So that's why normally you see people who have cancer and they are recovering from it, they tend to be quite sickly and ill because they're actually exposed to gamma rays, which are actually quite dangerous. So you need to be very, very careful when we deal with these three dangerous ones. Okay, they are not just dangerous, they are very dangerous. Okay, so just take note, for the first part here, your hazards, right? This is for all EM wave. Okay, then the one below is only for your energetic ones, or more specifically your ionizing radiation. Okay, so basically for all your EM waves, as long as you're exposed long period, you might actually heat up your body and you can end up with heat stroke or dehydration. Okay, but for your ionizing radiation itself, basically if you absorb them in large quantities, is that this will happen. Your molecules will become ionized. Now, if you all should have learned chemistry, right? Now ask yourself, are ions and your atoms the same thing? Obviously, they are not the same things, right? Otherwise, you would have different names. So the thing is, if your molecules become ions, your body don't recognize the ions. They are a totally foreign object, right? So what happens is that your body, your white blood cells, will start to kill your own cells. So basically, it will treat it as cancer, and then it will just keep trying to kill yourself. What happens is that your body will slowly break down, and you will cause very, very serious damage. You can cause sunburn, which is the least important. Least dangerous, you have cancer, and the worst thing is you will die. So as much as you can, always avoid being exposed to the sun. You see some people, they like to go to the beach and suntan without sunscreen. Those are people that don't want their life anymore. Okay, so always apply sunscreen, sunblock, and cover your whole body itself so that you can protect yourself against the harmful UV rays from the sun itself. Okay, then for X-rays and gamma rays, now if you have done an X-ray before, usually they'll actually ask you, have you done an X-ray in the past 6 months? So the thing is, X-rays, right, are quite harmful to the human body, but if you give the human body enough time to recover, the damage can be mitigated, so it can be reduced. Okay, but if you are pregnant, that's why for ladies, right, for the girls, if you ever do an X-ray, the first thing they'll actually check in with you is, are you pregnant? Have you been in any kind of sexual activities with your spouse or whatsoever? Because if you have a fetus and you expose it to X-ray, you can have a deformed baby. Okay, which is something very, very troublesome. So normally for your pregnant ladies, we don't use X-rays which are harmful. We'll use ultrasound, which is less harmful, and it wouldn't damage the baby itself. Okay, and take note, your ionizing radiation, which is this one, will cause cancers. So even your blood can also have cancer. So you can have blood cancers, your white blood cells are not producing as much, etc., etc. So all you need to remember is this chapter is one of the easier chapters itself. So they tend to combine it with your waves chapter itself as a part A or part B, just a small part of it itself. Okay, so you can just think of it as this is a subtopic for waves. Everything you learn in waves also apply for EM waves. Okay, and do take note, they are transverse waves and they can travel in vacuum. Okay, so your light that you learn is also a wave. So all your reflection, total internal reflection also applies for waves. More specifically for your all types of waves itself, they can reflect, they can also refract, and they can also total internal reflect as well. So just remember, the whole chapter of waves include your waves, your sound, your light, and these EM waves as well. So all in all, treat it all as one big chapter, read them all together as a whole, okay? Because when they want to overlap the chapters in your 10-mark questions, they will combine most of them together. Usually light is separate by itself, but I've seen some questions that mention about earthquakes having reflection and refraction itself. So you need to be very, very careful to take note of which is which.